Hi, my name's Tony Cotton, founder of Energy Conscious, and today we're going to share our experience implementing a smart DC lighting system that runs over Cat5 cable called LumenCache. This is the fourth in a series of videos, and this one is on LumenCache Installation, Do's and Don'ts. Recall from an earlier video that our implementation scope was limited to an emergency lighting system. It includes these two upstairs bedrooms, down this stairway, through the kitchen, to the family room, exit. All of these rooms backed up by a battery during grid outages. And our objective was to test as many functional aspects of the LumenCache platform as possible. Recall from our last video where we discussed cabling topologies, daisy chain versus the home run. In our case, the majority of our circuits were daisy chain since it was cheaper. Recall that the kitchen was a daisy chain flow. Light 2 to light 1 to switch 2 to switch 1. The only exception in our emergency lighting system was the family room. We needed a 4-way light switch, and we had old overstuffed metal boxes. Recall that in a home run, each device needs its own home run cable back to the panel. And this is the first room where we hacked cots were common off-the-shelf lights. Here we have the $20 Amazon LEDs that had external driver circuitry. All we needed to do was chop this black connector and attach it to a LumenCache SIB. Voila, we were good to go. But the Amazon light was 12 watts versus the smaller 6 watts that we were using for our daisy chain circuits. So the constant current driver could only carry 1, not 2, as we had in a daisy chain. So this was another reason why we had to go with a home run wiring topology. No matter which ceiling light we used, we don't need a can, which really saves on cost and installation complexity. You cut the hole, you connect the tip cable to the SIB, pop it in the hole, and you're good to go. The only trick is tipping the Cat5 cable, as we see here, while on a ladder. I let the young bucks do this. According to code, you can mix high voltage and low voltage if you have separator plates like this one. But when you have an existing mess such as we see here, it's just easier to add a separate box for the new low voltage, and you'll sleep better at night. We opted against using mud rings because there was no strain relief for hanging the SIB. However, if we had an open bracket box, such as this one, we could have used it and it would have supported the SIB. Once all the components are installed, it's time to tie them all together. Our favorite task, tipping. We used an easy RJ45 tool to do our tipping. All you have to do is push the unbraided 8 color-coded conductors through the tip to confirm the sequence of your wiring before you crimp. We also used a cable tester to check for a successful termination, And although we used it quite extensively in the early going, once we got good with the tipping, we were able to use it just for ringing out circuits or finding out which one was a bad termination. Once everything's tipped, just plug it all in and you're good to go. Finally, we come to the automation controller. Recall from an earlier video that we had selected an open source hardware platform called Raspberry Pi. We now needed to mount it in the structured wiring panel, and in checking through Amazon, we stumbled on an item called dinner plate for the Raspberry Pi. I'm going to have links to these and all the other items that we used in our installation, links to those devices in the show notes. So now all we need is the Raspberry Pi power. Recall that the whole reason for moving to the LumenCache architecture was so that we could use the solar DC directly, no converting it back and forth to AC. So there was no way we were going to put a surge protector and a wall wart in our structured wiring panel. Luckily, more checking on Amazon allowed us to find a 12 to 5 volt DC converter. No surge or wall wart. Plus, the LumenCache automation would now be on backup power. So if the grid goes out, not only do we keep the lights on, but the automation stays up and running. And a last minute addition was a DC power meter to support our demo board. Talking about efficiency is one thing, but showing hard data is the only way to make it real in my world. So what should we take away from this particular video clip? Number one, have a good plan with good diagrams. Have wire labels pre-printed for the Cat5 terminations. Definitely avoid mixing high voltage and low voltage whenever possible. Have all your materials, tools, and test equipment on hand. And if structured wiring is new to you, practice, and more practice until you're comfortable doing tipping on a ladder, for instance. Most of all, take your time and have fun. The rewards will come from living with energy savings, resilience during grid outages, and the fun you can have with the automation. We believe your home can be energy conscious.